Carbohydrates and exercising. So during exercise, the macronutrient, the only macronutrient that provides energy without oxygen and is largely the energy contributor, are the carbohydrates. So during intense exercises, the stored muscle glycogen and the blood-borne glucose are primarily utilized as the total energy required during an intense workout, and also as in the early few minutes of exercising when oxygen supply fails to meet the acceptable metabolism demands. In the early minutes of exercise, muscle uptake of glucose increases sharply and continues to increase as the exercise progresses. After 40 minutes, glucose uptake increases 7 to 20 times more at rest. The glycogen becomes preferential energy fuel and is an advantage because it supplies energy twice as rapidly than the fats and proteins. During moderate and prolonged exercises, in the transition from rest to submaximal exercise, almost all energy comes from our glycogen that is stored in the active muscles. Over the next 20 minutes, the liver and muscle glycogen provides approx 40 to 50% of energy requirement, along with our fat metabolism and the glucose present in the blood. As exercise continues, the glycogen stores depletes and thereby the fat metabolism increases and contributes to the total energy. Thereafter, the blood-borne glucose becomes the major source of limited carbohydrate energy. Eventually, as the liver glucose output doesn't keep up with its use and blood glucose concentration declines towards hypoglycemic levels, endurance athletes commonly refer to fatigue under the condition of severe reduction in the liver and the muscle glycogen, and they say it as a hitting the wall sort of situation. So the key role of our blood glucose in CNS functioning. The muscle glycogen and muscle glycogen's role as a primer in the fat breakdown. The relatively slow rate of energy release from fat as compared to carb breakdown. All these reasons contribute to the carbs depletion coinciding with the onset of fatigue in submaximal exercise. The energy requirement of exercise depends on two factors when it comes to fats during exercise. It is fatty acid releasing from triacylglycerols in the fat storage sites. The delivery in circulation to muscle tissue as free fatty acid bound to the blood albumin. Also, the tags stored within the muscle cell contributes to the exercise metabolism, energy metabolism. With greater dependence on fat catabolism, for example, with carb depletion, the exercise intensity reduces to a level governed by a body's capacity to mobilize and oxidize the fat. When it comes to protein and exercise, protein catabolism occurs more during the endurance and the resistance training than during our resting stage. The athletes who train for about 2 to 6 hours a week should daily consume between 1.2 to 1.8 gram per kg of body mass, the protein. In the unavailability of energy from carbs increases the protein catabolism and accompanying gluconeogenesis that becomes important in the endurance exercises. It is also seen that minerals and exercise performance has an impact. So consuming mineral supplements above recommended levels on an acute or chronic basis does not benefit the exercise performance or enhance the training responses. We have seen that water loss, the sodium and electrolyte loss through kidney and sweat, that triggers or impacts the exercise performances, leading to heat cramps, heat exhaustion, heat stroke, or heat syncope.